Hello students, myself Amrita Dhar, Assistant Professor of Electrical Engineering Department of Greater Kolkata College of Engineering and Management, JIS Group. Now, I will teach you switchgear and protection.
In this video, I will discuss about isolator and RCCB. These topics are included in Module 2 of the subject Switchgear and Protection. Subject code is EE/S5/SWGRP. Next is the RCCB. Now, while electricity has become an indispensable component of our lives, the fact is it comes with its own hazards to human life and property. Electrocution and fire being the major risk associated with the electricity. One cannot afford to be negligent when it comes to insulating equipment. RCCB is an important safety measure when it comes to protection of electrical circuit. It is a current sensing device which can automatically measure and disconnect the circuit whenever a fault occurs in the connected circuit or the current exceeds the rated sensitivity. Now, aimed at protecting an individual from the risk of electric shocks as well as electrocution and fires, RCCB is particularly helping instances of sudden earth fault. The presence of RCCB ensures that in such cases, the circuit will trip immediately and the person is thus protected from an electric shock. Next, working principle behind RCCB. RCCB works on the principle of Kirchhoff's law, which states that incoming current must be equal to outgoing current. RCCB thus compare the difference in current values between the live and neutral wires. Ideally, the current flowing to the circuit from the live wire should be the same as the flowing through the neutral wire. But in case of fault, the current from the neutral wire is reduced, and the differential between the two is known as residual current. On spotting a residual current, the RCCB is triggered to trip off the circuit. A leased circuit included the residential current devices ensured that the reliability of RCCB is tested. When the test button is pushed and the current starts to flow through the test circuit, as it creates an imbalance on the neutral coil of the device, the RCCB trips and supply is disconnected, thereby checking RCCB's reliability. Classification of RCCB. There are two types of RCCB: two-pole RCCB, four-pole RCCB. Two-pole RCCB is used in case of a single-phase supply connection that has only a live and a neutral wire. Four-pole RCCB is used in case of three-phase supply connections. Sensitivity of RCCB. A human being is able to sustain an electric shock to extent 30 mA, while up to 10 mA just evoke a prickling sensation. 10 mA onwards may lead to muscular contraction, further leading to a respiratory paralysis at around 30 mA. RCCB are therefore designed to look for small changes in residual current in cases where protection from the fire is sought. RCCB are also used to track higher changes in residual current up to 300 mA. Now, what are the benefits of RCCB? It provides protection against earth fault as well as any leakage current. It automatically disconnects the circuit breaker when the rated sensitivity is exceeded. It offers possibility of dual termination both for the cable and busbar connection. It offers protection against the voltage fluctuation as it includes a filtering device that guards against the transient voltage level. What are the limitations of RCCB? RCCB does not guarantee to operate if non-standard waveforms are generated by loads. It's mainly because RCCB is designed to operate on normal supply waveform. There might be some unwanted tripping of RCCB. It mainly because of whenever there are sudden changes in electrical load, there can be small current flow to earth, especially in old appliances. RCCB does not protect from current overload. It has been designed to protect only when the live current and neutral current are different. However, a current overload cannot be detected. RCCB does not protect against line neutral shocks, it mainly because current in them is balanced. The current gets balanced as both terminals are held, and RCCB does not protect the overheating that strike if conductors are not properly screwed into the terminals. Now, what is the main difference between MCB, RCCB and isolators? Isolators are generally used in power system, while on the other hand, MCB is the circuit breaker. Isolators are manually operated device, and on the contrary, the circuit breaker is the automatically operated device. Isolator cut the portion of the substation when a fault occurs. The other device like MCB or RCCB operate without any interruption. The circuit breaker is the device of automatic circuit breaker or miniature circuit breaker which treats the entire system, and if any fault occurs, MCB is to protect the wires from the damages. Whereas on the other hand, RCCB residual current device protects the life-threatening problems. RCCB detects the leakage current and protects from the electric shock. Now there is a difference. Now we discuss about difference between ELCB and RCCB. ELCB is earth leakage circuit breaker. RCCB is residual current circuit breaker. ELCB is voltage operated device. RCCB is current operated device. Fault detection, ELCB only detects earth fault that flow back through the main earth wire. RCCB will detect any earth fault, that's why they are using now instead of ELCB. According to connection, ELCB connected to phase neutral as well as earth wire, but RCCB is only connected to phase and neutral wire. ELCB needs an earth connection itself to install. Now RCCB do not require earth connection to install. Now according to types, they are same. Next, nuisance tripping is less in ELCB, it's high in RCCB. Cost, ELCB is more costly than RCCB. Application, it is not recommended, replace it with RCCD. Now almost all wiring system use RCCD nowadays. Now circuit breaker always strip the circuit, but open contacts of the breaker cannot be visible physically from the outside of the breaker. And that is why it is recommended not to touch any electrical circuit just by switching off the circuit breaker. So for better safety, there must be some arrangement so that one can see the open condition of the section of the circuit before touching it. The isolator is a mechanical switch which isolates a part of the circuit from the system as when required. Now electrical isolators separate a part of the system from rest for safe maintenance work. So the definition of the isolator is, an isolator is a manually operated mechanical switch which separates a part of electrical power. Isolators are used to open a circuit under no load. Its main purpose is to isolate one portion of the circuit from the other and is not intended to be opened while current is flowing in the line. Isolators are generally used on both ends of the breaker so that repair or replacement of the breaker can be done without any danger. Now types of electrical isolators. There are different types of isolator depending upon the system requirement: double break isolator, single break isolator, pantograph isolator. And depending upon the position in the power system, the isolator can be categorized as bus side isolator, line side isolator and transfer bus side isolator. Now the constructional features of double break isolator. These have 3 stacks of post insulator, and you can see in this picture. The central post insulator carries a tubular or flat male contact which can be rotated horizontally with a rotation of central post insulator. This rod type contact is known as moving contact. The female type contacts are fixed on the top of the other post insulator which fitted at both sides of the central post insulator. The female contacts are generally in the form of spring-loaded figure contacts. The rotational movement of male contact causes to come itself into female contacts and isolator becomes closed. The rotation of the male contact in the opposite direction make it out from the female contacts and isolator becomes open. Rotation of the central post insulator is done by a driving lever mechanism at the base of the post insulator, and it is connected to operating handle or motor of the insulator through a mechanical rod. Next one is the constructional features of single break isolator. The contact arm is divided into two parts. One carries male contact and other carries female contact. The contact arm moves due to the rotation of the post insulator upon which the contact arms are fitted. Rotation of both post insulator stack in opposite to each other and causes to close the isolator by closing the contact arm. Counter rotation of both post insulator stacks open the contact arm and the isolator becoming off position. This motorized form of this type of isolator is generally used, but an emergency hand driving mechanism is also provided. The pantograph type isolator permits current switchgear installation and it requires the least space. This type of insulator includes a post insulator as well as an operating insulator. Next is the earthing switch. Earthing switches are mounted on the base of the line side isolator. Earthing switches are usually vertically broken switches. Earthing arms usually are aligned horizontally at off condition during switching on the operation. These earthing arms rotate and move to vertical position and make contact with the earth female contacts fitted at the top of the post insulator stack of the insulator at its outgoing side. The earthing arms are so interlocked with the main isolator moving contact that it can be closed only when the primary contacts of the isolator are open position. Similarly, main isolator contact can be closed only when the earthing arms in open position. Next is the operation of an electrical isolator. As no arc quenching technique is provided in isolator, it must be operated when there is no chance of current flowing through the circuit. No live circuit should be closed or opened by isolator operation. A completely live closed circuit that must not be opened by isolator operation. And a live circuit must not be closed and completed by isolator operation to avoid huge arcing in between isolator contacts. That is why isolator must be open after circuit breaker is open, and this must be closed before circuit breaker is closed. The isolator can be operated by hand locally as well as by motorized mechanism from a remote position. Motorized operation arrangement cost more compared to the hand operation, hence decision must be taken before choosing an isolator for the system whether the hand operated or motor operated economically optimum for the system. For voltages up to 145 kV, hand operated isolators are used, whereas for high voltages like 245 kV or 420 kV and above, motorized isolators are used. Next, isolator in substation. Depending on the voltage in the substation, isolator of that voltage level is used. They are used to disconnect the transformers, circuit breakers and busbar for repair and maintenance. As mentioned before, they are operated under no current condition, that is no load condition, only since they don't have rated making or breaking capacity. Next, isolator in microwave. The main use in a microwave is to isolate the reflected wave from the output side to the input side. It just sends the energy signals in one direction, that is from the input side to the output side, or it acts as a unilateral device. A mechanism with vertical and horizontal polarization is used such that energy cannot be transferred back to input side. It should have a non-reciprocal material at radio frequency. Ferrites are best ones with a combination of static magnetic field. Now applications. The main purpose is to disconnect or de-energize the circuit completely, and for this purpose they are used in substations, power generating station and signal isolation. It provides more safety for the operator as it ensures the total disconnection of the electrical system. It is provided before and after circuit breaker in high voltage system. First the circuit breaker operates, then this operates such that the equipment's busbar and transformers are safe. Now what is the difference between isolator and circuit breaker? The main difference between isolator and circuit breaker is an isolator is off-load switching, whereas circuit breaker is on-load switching. Circuit breaker is designed to operate under load condition as they have arc quenching mechanism. When an energized part is connected, arc is produced and it should be quenched, otherwise it will damage the equipment. Always isolators are operated after CBs are operated. After circuit breaker are operated. While connecting, first the circuit breaker is connected, then the isolator is closed. CB is operated after getting the fault signal from the relay to disconnect the faulty part from the healthy one with high current passing through that part. And then the isolator operates either manually or automatically depending upon the availability. Faults on overhead lines fall into one of three categories: transient, semi-permanent and permanent. 80 to 90% of faults of any overhead line network are transient in nature. The remaining 10 to 20% of faults are either semi-permanent or permanent. Auto reclose scheme in a high voltage system for re-energize the line after a fault trip. Auto reclose scheme in high voltage system for re-energize the line after a fault trip. Transient faults are commonly caused by lightning and temporary contact with foreign objects. The immediate tripping of one or more circuit breaker cleared the faults. Subsequent re-energization of the line is usually successful. A small tree branch falling on the line could cause a semi-permanent fault. The cause of the fault would not be removed by the immediate tripping of the circuit, but could be burned away during a time-delayed trip. High voltage overhead lines in forest areas are prone to this type of fault, and it must be located and repaired before the supply can be restored. Now, auto reclosing is a movement of auto recloser. In electric power distribution, automatic circuit reclosers are a class of switchgear which is designed for use of overhead electricity distribution networks to detect and interrupt the momentary faults, and these are also known as reclosers or auto reclosers. Now, auto reclosers are essentially high voltage rated circuit breaker with integrated current and voltage sensors and a protection relay optimized for the use as an overhead network distribution protection asset. For overhead distribution networks, the majority of faults are transient, such as lightning strike, surges or foreign objects coming into contact with the exposed distribution lines. By this logic, 80% of the outage can be resolved by a simple close operation. Reclosers are designed to handle a short close opening duty, where electrical engineers can optionally configure the number of attempted close operation prior to transitioning to a lockout stage. Reclosers were invented in the mid of 90s in USA. Some of the earliest reclosers were introduced by Kyle Corporation in the early 1940s. The brand was the industry leader in reclosers and sectionalizers and the switchgear until the 2000s, when many other manufacturers entered the market. Reclosers were originally oil-filled hydraulic device and rudimentary mechanical protection relaying capabilities. Modern automatic circuit recloser are significantly more advanced than the original hydraulic units. The advent of semiconductor-based electronic protective relay in the 1980s resulted in increased sophistication, allowing for differing response to the various cases of abnormal operation or a fault on distribution networks. The high voltage insulation and interrupting device in the modern recloser typically consists of a solid-state dielectric insulation with vacuum interrupts for the current interruption and arc quenching. Reclosers are often used as a key component in smart grid as they are effectively computer controlled switchgear which can be remotely operated and interrogated using SCADA or other communication. This capability allows utilities to aggregate data about their network performance and develop automation schemes for power restoration. This automation can either be distributed or centralized. Is protected with the circuit breaker or fuses, which will turn off the power in the event of a short circuit. This presents a major problem while dealing with the transient event. For instance, tree limb blown off a tree during a windstorm that lands on the power line may cause a short circuit that could cause damage. However, the fault could quickly clear itself as the limb falls to the ground. If the only protection system is provided by breakers at distribution substation, large areas of the distribution network could be blackout while repair crews reset the breakers. So reclosers are programmed to automate the reset process and allow a more granular approach to service restoration. The result is increased availability of the supply. Reclosers addresses this problem by further dividing the network into smaller sections. For instance, the city grid example above might be equipped with the recloser at every branch point on the network. Recloser, because of their upstream position in the network, handle much less power than the breakers at feeder station and therefore can be said to trip at much lower power levels. This means that a single event on the grid will cut off only the section handled by a single recloser, long before the feeder station would notice a problem. Now, modern recloser installations are often equipped with SCADA communication, allowing the majority of recloser to be remotely operated by staff in the utility room. And this allows for switching the circuit, as operators can use information provided by the reclosers in the field to configure the distribution network if a fault is detected in the field or to fix the load flow issue. Remote control of recloser also saves significant operational expenditure as it can reduce the necessity of field crews to travel to site to reset devices which have transitioned to lockout. Auto recloser are made in single phase and three phase version and use either oil, vacuum or SF6 circuit breakers. Now, controls for the recloser range from the originated electromechanical system to digital electronics with metering and SCADA function. The ratings of reclosers run from 2.4 to 38 kV for load currents from 10 to 1200 ampere and fault currents from 1 to 16 kiloampere. On a three-phase circuit, a recloser is more beneficial than three separate fuse cutouts. For example, on a Y to delta connection, if cutouts are used on the Y side and only 1 out of 3 of the cutout fuse open, some customers on the delta side would have a low voltage condition due to voltage transfer through the transformer windings. Low voltage can cause severe damage to electronic equipments, but if a recloser were used, all three phases will open, eliminating the problem. Next is the reclosing principle. Whilst original hydraulic recloser designs had rudimentary protection capabilities, modern semiconductor control device exhibits sophisticated control system which allow for the configuration of varying responses to different classes of faults on the distribution network. The number of reclose attempts is limited to a maximum of 4 by recloser standards. The basic philosophy of reclosing is to activate Actively consider the fault cases and provide an effective response based on the fault type. This is done on a probabilistic methodology in conjunction with the detection of fault type. The most common fault type of an overhead distribution network is lightning strike. Lightning surges causes an increase in voltage which can cause localized breakdown of the insulation. Allow arcing over insulators. Recloser can detect this as an overcurrent or arc fault. For lightning surges pass very quickly, so the first reclose operation of a recloser can be configured to both trip and reclose quickly. The first reclose allows for interruption of the arcing caused by lightning but restores the power quickly. If the recloser closes onto a fault, it is likely that the fault is a secondary class of fault, vegetation contact or equipment failure. An overcurrent fault would indicate a line-to-line class fault, which can be confirmed by negative phase sequence overcurrent protection, whereas an arc fault can indicate a line-to-ground or double line-to-ground fault. Recloser can then apply a fuse burning policy where they remain closed for a short period to allow fuses on lateral lines to burn, isolating the fault. If the fault is not cleared, the recloser trips open again. This policy can be used to deliver energy to fault sites to burn the fault of line. This could be a branch crossing between the multiple lines or coming into the contact with the conductors. Sensitive arc fault protection in recloser is typically set to immediate lockout. This detection of small leakage current less than 1 ampere on a medium voltage line can indicate insulator failure, broken cables or lines coming into contact with trees. There is no merit in applying reclosing to this scenario, and the industry best practice is to reclose on sensitive arc fault. Recloser with sensitive arc fault protection capable of detecting 500 mA and below are used as a fire mitigation technique, as they provide an 80% risk reduction in the fire starts. However, they are never to be used as reclosers in this application, only as single shot distributed circuit breakers which allow for sensitivity to verify the existence of these faults. Application. Traditional reclosers were designed simply to automate the action of a line crew visiting a remote distribution site to close a tripped circuit breaker and attempt to restore power. With the advanced protection functionality of modern reclosers, these devices are used in a multitude of additional applications.
That's all from today's class. If you have any problem, please contact with me. My contact details is given on the first slide. Thank you.